Question 1, what is the solution to the given equation? So you can probably just eyeball this. 3k plus 2k is 5k equals 5. Divide both sides by 5 and k equals 1. Question 2, what is the graph of the equation y equals 3 to the x? So this is an exponential equation. You should have memorized that any exponential equation is going to look like choice A. I usually have people memorize 2 to the x. You know that because if you were to plug in 0 for x, you get 2 to the 0, and anything raised to the 0 power is 1. So an exponential equation is always going to cross the y-axis at point 0, 1. So this kind of does look like y equals 3 to the x. Let's compare the rest of the graphs and just to see that there's nothing very similar. Choice B, notice what's going on. They've actually translated the original graph in choice A and they've moved it 2 units down. So that's simply saying y equals 2 to the x. A translation of 2 units down is subtract 2. So B is not going to be it. Choice C, notice what they did to the graph. The original looks like this, and they flipped it over the x-axis. So when you reflect something over the x-axis, you do that algebraically by negating the entire equation or the y. So this is actually going to be y equals negative 3 to the x, or y equals negative 2 to the x. You'd have to verify by plugging in numbers. Choice D, notice that D is the same as C except translated 2 units down. So this would be y equals negative 3 to the x minus 2. So C and D are out and the answer is going to be A. Question 3, for the quadratic function f, the table shows some value of x and their corresponding values of f of x. Which of the following could be the graph of y equals f of x? So this is obviously a table. It should look like a table. What you'll notice is that this is most likely a parabola if you glance at the answers. There is symmetry about the y-axis because notice what the points are. 0, negative 4, so that's 1 point. Negative 1, 0. And then 1, 0. So if this is a quadratic function, then it probably does look like that, and your points of intersection are 0, negative 4, negative 1, 0, and 1, 0. So A so far looks like the answer. Choice B, notice that it's 0, 4, not negative 4, so that's out. Choice C, we don't have the points negative 1, 0, and 1, 0, so that's going to be out. We've got something like 1, negative 5. I don't know what that is. Choice D, we also don't have the vertex. This is 0, 4, and not 0, negative 4. So that's going to be out also. Question 4, in the given quadratic equation f, c is a constant and f of 2 equals 12. So this is nice because they're basically telling us 2, 12 is an ordered pair that will solve this. Let's plug it in. 12 equals 3 times 2 squared. Plus 4 times 2 minus c, and this is simple algebra. So 2 squared is 4 times 3 is 12, plus 4 times 2 is 8, minus c, all equals 12. 12 minus 12 is 0. Subtract 8 from both sides, or rather let's add c to the left side, so we get c equals 8, and the answer is going to be A. Question 5, we've got an equation with 2 unknowns. A person used a total of 265 kilocalories while walking and running on a treadmill. Running at a constant rate required 11.5 kcals per minute. So that's obviously running up here. And walking at a constant rate required 3.5 kcals per minute. So this is walking, just so we don't get mixed up. The relationship between the number of minutes running, x, and the number of minutes walking, y, is given by the equation shown. If this person ran for 20 minutes, how many minutes did this person walk? So since x is the number of minutes running, we plug in 20 for x, and then we solve for y. So 11.5 times 20 plus 3.5 times y, that equals 265. And 11.5 times 2 is going to be 23. And since it's times 20, just move the decimal place over. So it's going to be 2230 plus 3.5y equals 265. And subtract 230 from both sides. We get 3.5y equals 35. And you can just estimate 3.5 into 35 is obviously going to be about 10 times, and D is going to be the answer. Question 6, we've got a complex fraction. Which of the following is equivalent to the given? So if you have no idea how to do this, you could pick a number for x, say x equals 2, figure out what the top value is, and then plug in x equals 2 for each of them and see if any of them match. This is number 6, so we can actually do it the real way. It's not that hard. The way I like to solve complex fractions is multiply the top and the bottom by the greatest common multiple, or the least common multiple rather, of both denominators. So here the denominator is 1. Up here the denominator is x. So if we multiply the top and the bottom by x, notice we're actually multiplying the whole fraction by 1. So we're not changing the value. When you multiply the top by x, the x's divide out, you get 6. When you multiply the bottom by x, you get 18 times x, which is 18x. And then if you divide this out, 6 into 18 is 3, so it becomes 1 over 3x, and that's choice B. Question 7, in the figure shown, C is the center of the circle, AB is tangent at A. Which of the following is true about the measure of angle BAC? So this is just something you should know. Whenever you are drawing a tangent to a circle and you connect that with a radius, this is always going to be a right angle. So really the answer is choice C, and if you had memorized that, there's really just no thinking about it. You could think about this visually, right? I mean, in a more theoretic way. Let's imagine you've got a circle. You draw a vertical line that way, and then let's imagine you take a stick, right, and you lay it on top of the circle or the wheel. Let's pretend that that's touching. Now imagine that this is like a seesaw, right? As soon as someone gets on this side and the seesaw goes down like this, now the point of contact on this circle is now going to move this way. So as soon as you adjust this angle, which is 90 degrees, now you're making a new 90-degree angle to a new point on the circle. And so that is kind of my visual proof for why any tangent drawn to a circle where it connects at the radius is going to be equal to 90 degrees. I'm sure there are better proofs out there and you guys can look those up, but visually you can keep it in mind like that. Question 8, the graph of the function f is shown. What is the value of x for f of x equals 0? So notice what they're saying. They're giving us the y value, which is 0, and they want us to figure out the x value. So this is really easy. The y value is 0 on the x-axis. That's right here. So what's this point? It's 3, 0. So if we were to rewrite this properly, it would be f of 3 equals 0. In other words, when x is 3, y is 0, and so the answer is going to be D. Question 9, we've got an equation and it shows A in terms of P, R, and T, where P and R are not equal to 0, which equation gives T in terms of A, P, and R. So basically the idea is if you want T in terms of all the others, you want T on one side of the equation and all the letters and all the numbers on this side. And the reason they're saying that P and R are not equal to 0 is so that when we divide by P, or if we have to, that we can actually do that because you can't divide by 0. So basically this means let's get R by itself. So I notice we've got two factors, this times that. Let's divide both sides by P. We get A over P equals RT plus 1. We can't split this up. We have to subtract 1 first. So A over P minus 1 equals RT. And then to isolate the t, we're going to divide both sides by r, or you could think of it as multiply both sides by 1 over r. That might be a little bit easier. Because notice in the answer choices, they do keep this part separate where you're subtracting things. So on the right side, the r's divide out, we get t. The left side, you've got to do each part. So the first part becomes A over RP minus 1 over R. And that means that the answer is going to be equal to C. Question 10, what is the volume in cubic units of the right triangular prism? So the way I like to think of these volume problems is first you want to get the area of one of the faces, And then once you get the area, to get the volume, you sort of bring the area into the third dimension. This is actually the same strategy as a rectangular prism that has, say, length, width, and depth or height. The reason it's length times width times height or depth is you're really taking one of the surfaces, length times width, and then you multiply it by the depth to bring that two-dimensional area into the third dimension. So same thing. So what's the easiest way to find the area of this triangle? Well, it's a right triangle already. So if we kind of rotated it and set this thing on this face, then we'd have a right triangle that looks like this, where your base and height is 6. So area of a triangle is 1/2 base times height. 1/2 6 times 6 is going to be 18. And then again, if this is 18, we bring it into the third dimension by multiplying by 10. The area is going to be 180. So that's all you need to do for that. Question 11. A hotel has a total of 180 rooms on a certain day. Half the rooms were cleaned. 9 housekeepers are on duty, and each housekeeper cleaned the same number of rooms R. Which of the following equations represents the information given in terms of R? So to me, the easiest part of this problem is you've got 9 housekeepers cleaning R rooms. So the total number of rooms cleaned is going to be 9R. And they're saying on that day, half of the 180 rooms were cleaned. So I was thinking 9R equals 1/2 of 180. And then if you kind of move stuff around, really just multiply both sides by 2, you're going to get 2 times 9R equals 180, and that's going to be choice A. Question 12. A patio is made using square paving stones that are all the same size. There'll be no gaps between the paving stones, and they will not overlap. The line represents the relationship between the area of the patio and the number of paving stones. So I'm just going to write number here and area up here. This is technically the number of stones used to make the patio. The top surface of each paving stone is a square with side length k, and they want to know what the value of k is. So probably the easiest way to do this is really to just pick a point, because no matter what you pick, the relationship has to stay the same. So the easiest one is down here. So this is saying that when we use 2 paving stones, the area is going to be 8. So why don't we just put them right next to each other? And if the area of these 2 is 8, then the area of each of them is 4. And if they're squares, then each side has to be 2. And that tells us that k is equal to 2. Notice this would have worked if we picked any other point. Let's say we used 4 paving stones, and they said the area here is 16. Then 16 divided by 4, we would have found that each square is also worth 4, and each side of the square is also 2. So k would have been 2, no matter what point we picked on the line. Question 13, line L is shown in the plane. Which of the following is an equation of line L? All right, so obviously the easiest thing to do is figure out what the equation is just by looking at it. We know the y-intercept is 2, and we know the slope, rise over run, 2 over 1, 2, 3, 4, 5 boxes. So slope is 2/5 negative because it's tilting that way. Y-intercept is 2, so if we went further, it's going to be y equals negative 2/5 x plus 2. We probably don't have to go that far. We basically just need to go through each of them and see which is going to give us a slope of negative 2/5. So if you can do this in your head, the easiest way would be move 2y to the other side, and then you're going to go 2y, or add 2y to both sides, equals 5x minus 10. Notice what's going to happen when we divide both sides by 2. You're going to get positive 5 over 2 for the slope. So a is not going to work because we need negative 2/5. Do the same thing here. Subtract 5x from both sides. We get 2y equals negative 5x plus 10. Divide by 2. The slope is going to be negative 5 over 2. Again, not what we need, so b is out. Same thing here. I know 5y is going to equal 2x minus 10. Slope is going to be positive, so c is out. And so that leaves D as the only choice. 5y equals negative 2x plus 10. And when we divide both sides by 5, yeah, we're going to get negative 2/5 for the slope, and then we're going to get positive 2 for the y-intercept. So D will be the answer. Question 14, we've got a system of equations. It says n is a constant. It has no solution, and what is the value of n? So on the SAT, whenever they ask you questions about no solution, one solution, infinite solutions, you want to make the equations as close to each other as possible, and really you need to get them to say the same thing. So what do I notice first? We've got, for the x's, we've got nx and 12x. That's fine, we don't know what n is, but we've got 3y and 6y. So I really want these to say both the same thing in terms of y. I'm going to multiply the top equation times negative 2, because that's going to give us negative 2nx minus 6y equals negative 2. The bottom equation we keep the same, 12x minus 6y equals 0. So now notice what we've got. We got the top equation equal to 2, the bottom equation equal to 0. So if we set them equal to each other, which they're not, 2nx minus 6y equals 12x minus 6y. We know the left side is equal to negative 2, the right side is equal to 0, so this equation is already not equal to each other. So if we can make the left and the right side say the same thing, then we know no matter what values we plug in for x and y, they're not going to be equal to each other. So let me show you. Add 6y to both sides, and that eliminates that. So we get negative 2nx equals 12x. Divide both sides by x, and we get negative 2n equals 12. Divide both sides by negative 2, we get negative 6. And so that's actually going to be the answer. Question 15, which is equivalent to that. I always like to change my radical signs into fractions because this is just an abstraction. So this is really 16a to the 16 all raised to the half. Since we're multiplying these things out, we could split it up. 16 to the 1/2 times a to the 16th to the 1/2. 1/2 means square root, so the square root of 16 is 4. Rules of exponents say when you raise one to another, you multiply it, so this becomes a to the 8th. And so the answer is choice B. Question 16, the graph of y equals 3/5 x minus 8 is a line. What is the slope? So you've memorized y equals mx plus b. It's kind of staring us in the face. The slope is 3/5. So again, once the math section goes to free response, the difficulty level drops, so keep that in mind. Question 17, we've got a system of equations. The solution is x comma y. What is the value of x? So quick strategy point, if you're solving for x, or they want to know x, let's eliminate y, because that'll eliminate some steps for us. So we got positive 2y, negative 3y. I'm going to multiply the top equation by 3, because that'll give us 6y. Bottom equation by 2, because that'll give us negative 6y. So we've got 9x plus 6y equals 24. Bottom, we've got 8x minus 6y equals 10. We're going to add them together. When we do, the 6y's drop out. We get 17x equals 34. Divide both sides by 17. We get x equals 2, and that's the answer. Notice if we solve for y, we'd have to plug y back into the equation, then solve for x. Not that hard, but it's another step that might make you make a mistake. Question 18, right triangle XYZ. So we'll do X, Y, Z. The sine of x is equal to the cosine of 20. By the way, I don't really know if y and z are there, but we know that x is one of the acute angles. So we don't even need a diagram. Notice what it says. The sine of x is equal to the cosine of 20. What you should have memorized is that the sine of any angle is equal to the cosine of its complement. So what does that mean? Cosine of 20 is equal to the sine of its complement, which is 90 minus 20, because complementary angles add up to 90. So cosine of 20 is going to always be equal to the sine of 70. And you can actually check this on your calculator. So x is going to be 70 degrees. The reason real quickly that works, why is the sine of x equal to the cosine of its complement? Because notice where these are positioned on the triangle. The sine of x is going to be equal to the cosine of z, because the side that's opposite x is the side that's adjacent to z. So that's why sine and cosine are called cofunctions, because the co stands for complementary. Likewise, the same thing. The sine of z is equal to the cosine of x, because the side that's opposite z is the same as the side that's adjacent to x. Question 19, absolute value equation. What is the sum of the solutions? So the best way to solve this is divide it into two cases. X minus 2 equals 3, or x minus 2 equals negative 3, because when you take the absolute value, they just care about the magnitude. Add 2 to both sides, x equals 5. Add 2 to both sides, x equals negative 1. The sum of the solutions is 5 plus negative 1, which is 4. Question 20, in the given equation, b is a positive constant. The sum of the solutions is 5. What is the value of b? So notice we've got 3 factors multiplied out together, a times b times c. And they all, when you multiply them out, the product is equal to 0. So that means either a is equal to 0, b is equal to 0, or c is equal to 0, and that'll make this true. So just eyeballing this, in case of a, if x is equal to 0, that's one solution. In the case of b, if x plus 3 is equal to 0, that tells you that when x is negative 3, that's a solution. In the case of choice C, when x is equal to b, that'll be another solution, because x minus b has to be equal to 0. So these are our 3 solutions. We got 0, negative 3, and b. So 0 plus negative 3 plus b equals 5. And so we add 3 to both sides, b equals 8. And so that's going to be the answer.